I know.
Woo.
Yeah,
Amazing story.
that's brave.
You know, and William Beebe's like bathysphere was
Bathysphere, yeah.
in the 30s,
But
the late
that's
30s.
definitely
You know,
not an ROV.
that's not an ROV. That's
So
just a
yeah,
person in a sphere
right.
lowered, bobbing up and down like a
And
tea
you could
bag.
say
Yeah.
Argus is or Angus was more of a just a camera sled, right? It wasn't an ROV. It's just dangling on the end of the rope. And,
Okay, so it,
Yeah, our definitions will matter a lot on the
yeah.
answer.
You know, it had cameras and strobes and stuff, but you didn't get real-time data up to the surface. So
you of course not, yeah.
yeah,
You had somebody in there with a camera.
yeah.
Looking out a window.
If you not only look backwards at what has been accomplished and changed and improved since the early days, but then transpose that and look forward, we have
Wow.
all these autonomous surface vessels, gliders, autonomous underwater vehicles coming into play.
Sail drones. Yeah.
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 So many innovations.
It's good because it's like a lot of it's like infrastructure for remote sensing, right? So you can collect more data on the whole versus like for things that like don't require sediment, like sampling, right? You can get you can characterize like the chemistry of the ocean.
Yeah,
everywhere.
environmental sampling is easy.
Yeah.
And mapping's very easy.
We're really looking forward.
The force multiplier.
Yeah.
We're really looking forward to using sail drones to map, you know, with multi-beam data, the seafloor and water column with these sail drones.
Yeah.
I mean, it would be so much more efficient than using a ship, so much more energy efficient than using a ship. And then you can just, hopefully, we're hoping that you can just give them a pattern and they'll drive it. And
yeah, Scripps just announced that they've been funded for the next regional class research vessel, and it's going to be hydrogen powered.
oh,
Wow.
really?
They just announced that?
Yeah, yesterday.
Awesome.
I think it was yesterday. Hard to tell days apart.
It's exciting.
Might have been Friday. Friday's a good news release.
4 in a row.
Probably wasn't Saturday, yeah. Fair enough.
We're really looking forward. If you want to check out the expedition page on Nautilus, you can check out some things we're doing in September, which will be some technology tests and demonstrations where we will be bringing more vehicles aboard Nautilus. So in addition to Hercules and Argus, we'll be bringing the DRIX autonomous surface vehicle, the Mesobot midwater autonomous vehicle, and the Myriad under ice, which is a hybrid AUV ROV onto Nautilus, and working on demonstrating those next, kind of the next generation, those next steps of autonomous and remotely operated dual operations, communicating with optical modems, with vehicles that aren't tethered to the ship, and just really, you know, it'll be a very different expedition. It'll be a lot of engineering trials and a lot of just testing a whole concept of operations to take this from kind of experimental and ideas to like, how do we do the work that we do, which is get in the water almost every day, really like punch that work out. And
so these are like prototypes of these vehicles, or have they already been developed?
They've already been developed, and you know, each work independently, you know, bring a lot of strengths to the table. The Mesobot and Myriad under ice are two vehicles from Woods Hole Oceanographic Institution, and the DRIX autonomous surface vehicle is from the University of New Hampshire, who have the fantastic Center for Coastal and Ocean Mapping. But it is the combination of these, and that comes from the Ocean Exploration Cooperative Institute that OET is part of. So that combination of forces is really what we're testing. That'll be in September.
Oh, that's awesome.
On Nautilus, right back in the port of Los Angeles, Southern California.
I know that Dana Yeager at Woods Hole was developing the Mesobot.
Dana will be out with us.
Oh, that's awesome. He's such a great guy.
Yeah, Mesobot's amazing. it can
So
study the midwater
and it can actually follow creatures up and down. I sailed with him about 5 years ago when had just started developing it. Oh, awesome.
I have like the faintest connection to the Mesobot. Right after I got my Nautilus intern, I started an internship at a place down the road from Hui called Marine Imaging Technologies. And they had us like fabricate a like mock Mesobot body so that they could in like real life see that all the instruments would fit where they wanted it to. They made like a wood version of what the body style would be so they could mock things up on it. Now it's a fully fledged vehicle.
How big is it?
Cool.
I don't know the exact dimensions.
Smaller than Drix.
Smaller than Sentry. Yeah.
Yeah.
Oh, that's good.
I think it's maybe like 1.5 meters tall. Let me see. I can get the right information. We don't have to make it.
Interesting.
But that means at some point, if you are going to be conducting vessel operations, especially with an ROV, you could come on site, deploy one or more Drix to go and do mapping around you and some mesobots to do midwater column, and you go down and do your work on the bottom, and you collect a massive amount of data, and then move on to your next area of interest.
Or send, the goal for Drix vehicles, and I think where they're very close to doing is over the horizon. So the concept being that a Drix vehicle could supervise something like a Mesobot in the midwater and could go ahead of the ship, work in an area as Nautilus finishes a remotely operated dive in another place. And you could kind of hopscotch in that way, collect your mapping data before you arrive to a site.
So the Drix is a mapping vehicle.
It has both midwater mapping and seafloor mapping.
That's probably seaweed, huh?
Mesobot is 1.5 meters long, 1.5 meters tall, and about 1 meter wide.
So a nice, tidy little thing. That's good. So how far do we have, Chris, till we get to the target?
Looks like about 1 kilometer.
Okay.
Maybe another hour to go.
Oh, really? Okay. Just in time for tomorrow to come on her shift and find the hydrate and all the gas bubbles. Yeah, talking about all those different vehicles and all the data that they'll be collecting as a person who analyzes data, it makes kind of like a headache. We're going to have to hire a lot more people.
Or leverage AI to do a little more of that.
Oh, there you go.
Well,
replace us with robots. For the robots that collect the data and then have robots process the data.
And have robots that fund the research.
Yeah. Yeah, exactly.
Yeah.
Oh my.
And I think that's, that's part of the fun of like these operational tests is, figuring out how the decision making can go. The autonomous systems still need a lot of constraints provided about, site planning and mapping, mission planning. And I feel like that field is advancing so much with, with sail drones, with these autonomous, vehicles that are going out and doing more and more heavy lifting. It's still, the prioritization and understanding, how and why we want to look where we want to look, in the ocean. We don't just, close our eyes and pick a point on the map and drive Nautilus to there and put the vehicles in the water. But, figuring out how we prioritize what we learn and what we go explore while there is so much left to know.
Can we speed up or not and still see the bottom?
We're already going pretty quick.
Are we?
Normally we don't like to go too much faster than half a knot. I don't know. What do you think, Bob?
Yeah, we can bump it. It's pretty flat. I mean, we haven't touched the winch, so if we don't have any surface or bottom topology there, maybe we can go a little bit faster, 0.7
Yeah, 0.7.
perhaps.
All right,
Hey,
I'll
let's
ask him.
pedal to the metal.
Bridge nav. Can we increase speed to 0.7?
Thank
Kylie's
you.
just gonna have to stay out on the bleeding edge here.
Well, your camera is
Yeah,
looking
we'll see if
straight
the
down too, so I have like a little bit more out in
Yeah.
front that I could get
Yeah.
than the view currently.
Yeah, I think we're fine.
It is totally flat until you see
Yeah.
the canyon wall.
Yeah.
we'll have to see if the ship will even do that. It's been working pretty hard already, so.
Really?
Roger.
Yeah. Well, we're already up to 0.6, so maybe. But the thruster is like maxed out.
Yeah. There's pretty strong surface current.
Yeah,
I think we're going into it, right?
we are, yeah.
Yeah.
And into the 18 knot wind too.
Yeah.
Roger.
Okay, well, I don't want to mess with a good thing.
Well, it made it to 0.7, so
All right,
looks like we're
perfect.
in good shape. This new DP system has made a huge difference.
So you got a new DP and a new engine and...
Yeah.
Yeah. But the DP is not using the main engine yet.
Yet? Is
There's plans
Yeah.
to use the main engine with the DP. Yeah.
Wow.
Yeah.
So DP is dynamic positioning, in case anybody at home is listening. So
Yeah,
what is
Chris,
it using?
It's using the jet pump on the aft and the bow thruster forward. So they're bringing in seawater and then shooting it out as a jet
Wow.
to push the vessel along. And also laterally.
So where is that new script ship going to get the hydrogen to power it?
I don't know. It wasn't
I'm
that
sure they've...
exhaustive of a press release about how that power plant was going to
Yeah, I'm sure they've figured that out, but...
And it's replacing the, what's it called, the Sproul?
Uh-huh.
The Scripps vessel that the RCRV is replacing. I think it's the Sproul.
Sproul.
Yeah.
Oregon.
They're slated to have it in 3 years, but that seems like an ambitious schedule with a futuristic
yeah.
power plant.
That would hopscotch some of the regional class ships. It was coming out that time.
Oregon State University is getting one of the new regional
Yeah,
class.
the first one, Tawny,
Yeah.
right off the bat.
Well, what do they have? 18 berths for science? Is that it?
Yeah, they're not a lot. That's not a lot.
And
They're quite a bit smaller than the
I think they can hold 2
world class.
containers and
They can have
only single stack.
They have additional berthing containers.
Yeah, you put a sleeper van on it.
Yeah, I think it's like 2 in a van or something like that. I think. URI is getting one of them. That'll be the Narragansett Dawn.
Yeah.
And there's one in the Gulf. Gilbert Mason. But I forget the institute that it goes to.
This is a big deal because we've been waiting and waiting and waiting for decades to get new ships to replace some of these aging vessels that we've been sailing on, and several of them have been decommissioned over the years and not replaced with anything. When we say UNOLs, we mean it's university vessels. They were basically provided to universities from the Navy. And some of those are getting really old.
Yeah.
They're wonderful ships to sail on. Myself and Ed's favorite is the research vessel Thompson from University of Washington.
Such a great platform.
Yeah. Almost 300 feet long.
I think it's 287 long, 60 feet in beam, 19 feet down.
And it can take on a very large science party.
Yeah, 30.
Yeah.
30 in the science party, 30 in the crew.
Yeah, the regional class ships are 60 meters, so they're just shy of
200.
a little shy of Nautilus.
200 feet.
Mm-hmm.
Yeah, it's good because like not only is it an aging fleet, but not all the ships in the UNOLS fleet have modern capabilities like dynamic positioning or fiber optic winches. So I'm pretty sure all of the RCRVs will have both of those capabilities to allow for things like ROV ops.
Well, most of the UNOLS vessels that are left, like the Thompson and the Ravel, I think are about it, right, Ed?
There's 4 Igor 23s, the Thompson, the Ravel, the Brown, and the Atlantis.
Right.
Yeah.
I think most of them,
And
they
the
went through
Thompson has just completed a
Those
year
are
and
all
a
world
half
class,
ago.
right?
midlife. They've
They're
gone through
midlife.
midlife,
Yeah.
and they've updated all of
Global
those.
class.
Yeah, Atlantis is getting.
It just took
Yeah.
off from
Yeah.
Anacortes, yeah. Yeah, and as we say class here, they're mean different sizes, so they kind of think about them like different teams of vessels. And the global class vessels are those that we're talking about, the biggest. The regional class will be its own smaller size.
But that's the thing is like even the Thompson, which is operated by the University of Washington, it's been doing work in South Africa and Australia, and
Sifona 4.
a regional class vessel can focus on that region and not be drawn around the world for different projects.
But then, ships like the Nautilus and the Falcor are not as large as those class
Oh,
vessels,
no.
and they go all over the world as well.
Yeah.
We've learned to
Yeah,
adjust.
the Sikuliak and the Lynxith are the others. I have my list here. Then your ocean class are your Kila Moana, Oceanus, Endeavor, Atlantic Explorer in Bermuda, the Neil Armstrong, and the Sally Ride. Those last two being the newest of those, launched in 2014. And then the regional class, there's currently only one, and it's at the University of Delaware, but we're adding 3 more, those that we just named, Narragansett Dawn, Tawny, and Gilbert Mason.
Sally Ride is a beautiful ship. I've toured it. I've not sailed on it yet, but it's also not an icebreaker, but can work in some ice.
Ice strengthened?
Yes.
Yeah, Sikuliak has an ice.
Oh, maybe I'm thinking of the Sikuliak. Maybe.
Yeah.
I bet Sally Ride does too. And then there's some local ones. Yeah, the Sproul at Scripps in Louisiana, the Pelican, the Skidaway, or the Savannah and Skidaway. And these are smaller. The Rachel Carson at the University of Washington. Those are good for doing
local work.
Yeah, local work at the University of Washington. A lot of that work does work in the Salish Sea and the protected waters, or smaller things like CTT cast trawls, local oceanography. So, you just, same thing with Nautilus and equipping the ROV with the tools you need. Different types of science just need different things. And
yeah. I sailed on Rachel Carson before the epidemic. It was a lot of fun out in Puget Sound. Looking at methane seeps.
Very nice.
With my colleague, Paul Johnson at University of Washington. And several people from our group.
Question coming in about these sea stars. Sea stars are recyclers. Sea stars are scavengers. They will, and predators. They were eating and digesting things that sink to the seafloor. If you have kids, sea stars may become their favorite. The way a sea star eats is it takes its stomach and it everts it out of its body, out of its mouth. So it pulls its stomach, up from inside its body and then out through its mouth, surrounds the food, secretes digestive juices, and then pulls that sort of liquefied-ish food and its stomach back inside its body, which almost got me uninvited from a Thanksgiving dinner after explaining sea stars to my nieces, but is a super cool fun fact.
Well, they must have a lot of sand in them.
Probably. You'll see them kind of,
Wow.
and so that's where you see them kind of like, whoa,
Yeah.
kind of up on top of things,
Yeah.
hovered over it with their arms, kind of in a
Wow.
clump. But some other things probably eat sea stars out here. They would be, I don't know what, but maybe.
I know they're kind of the top predator in a tidal pool, but
Yeah, I know. Maybe some sablefish or, I don't know, just depends.
I love their little 2 feet that help them move. So on their surface, they have this little disc that like water kind of will come through. And they actually move this water through so things called 2 feet that they use to move around and walk around the seafloor. So although they look like they're not moving, some of them may actually be, they just move a lot slower than we do. But I think, was that yesterday or the day before? Whenever we were diving last, we saw Rathmanaster moving pretty quickly. So it's pretty fun to watch them.
and
If you ever find one
that's
flipped
the
over, we can
great
show you their 2 feet.
Yeah, their own little hydraulic systems.
Yeah,
the
pretty impressive.
Rathanaster was the great big one with
Mhm.
like 20
with lots of
20
arms.
legs. Marine geologist here.
Oh, good. Yeah, the orange, red, brownish things going by are jellyfish. They're Paralia jellyfish. They have big bells and fairly small tentacles, but they're pelagic. They live their life up in the water here, capturing tiny things, those tiny tentacles.
Hmm? Oh. Okay.
Be good life to be a jellyfish here. There's a lot of stuff in the water.
Yeah.
Yeah, for a while I was seeing a lot more sea pens sticking out. They like to feed in the water column too. Polyps, they'll stick them out and use them to feed on organic material in the water column.
Mm-hmm.
Yeah.
Still see it. And those are considered octocoral, the sea pens.
Octo what?
Octocoral?
Octocoral.
I believe so are mushroom corals. So Heteropolypus, the pink fluffy things that we were thinking were anemones at first the other day, those are mushroom corals.
Octocorals as well. Yeah. All right. And that's the little red things we're seeing right now?
So you'll see some little, like right there, the little, like almost like a stick with fuzz sticking out of it.
Right.
Yeah, there's, we were seeing, I think, 2 different species of sea pens.
Uh-huh.
One was Umbellula, and I'm not sure what the other one is. You have to get a little closer.
We've also seen them on the outskirts of hydrothermal vents up at the Explorer Ridge. Got some beautiful pictures of them. Its jellyfish are beautiful. Suspense is building. We need to find some, hoping to find a nice piece of sampleable hydrate on this north rim, well, not on the rim, on the canyon floor, on the North Canyon floor, with a bubble stream sitting right next to it. That's what we're hoping for.
Yeah, that's the goal.
That's the goal, so we can sample this methane in its ice-like solid form, the hydrate, and in the gas form in the bubble stream. And Tamara can do her magic chemical analysis on them. We are traveling.
All of the equipment that we have now in the wet lab, all the processing is pretty impressive looking. I've never seen the wet lab that full with equipment.
Really?
Yeah.
With the gas line and, yeah. So we're traveling across Astoria Canyon. We are, let's see, about 30 miles off the coast of Oregon, Washington. The Columbia River is the divide between Washington and Oregon, and Astoria Canyon is basically formed, well, by the Columbia River. It has carved out this beautiful canyon that we're seeing. It has the highest flow rate of any river in the United States. It's not as long as the Mississippi, but it certainly has a lot more power. If you've seen it, you'd believe it. It's just absolutely beautiful. So we're about 30 miles off the coast right now. The headland of the Astoria Canyon is about 15 miles offshore and about 150 meters of water depth, which was the where the shoreline was at the before the end of the last ice age, and that's kind of why the mouth of the canyon is at that point. It extends for about 60 miles, 110 kilometers, to about 2,000 meters of depth, where it then empties out onto the Juan de Fuca Plate, the canyon's edge. And you can trace that canyon even onto the Juan de Fuca Plate for quite some ways. Let's see, the weird sea bubble streams we've seen identified, probably this is, well, these canyon heads, especially in Washington and Astoria Canyon, are prolific with bubble streams. First, in Astoria, some of the first identifications were made by fishermen from the fishermen flares. A colleague of mine, Paul Johnson, up at University of Washington, got a bunch of fishermen to give him positions of where they saw them in their sonar. And it all kind of started from there, here in Astoria Canyon. And fishermen knew that there were a lot of fish around these sites. So that was sort of the beginning of the hunt here. So we're going to try to find some of these bubble streams. One of the things that's interesting here is that so the canyon extends to almost 2,000 meters deep, but beyond the depth of 1,000 meters, we really haven't seen any bubble streams. So that's also kind of interesting. Maybe we haven't looked hard enough, but I tend to believe that nothing has stood out to us. So even though these bubble streams, we really don't find we find quite a lot of them down to about 800 meters, sort of the edge of the slope. But beyond that, we find them at slumps and fractures and where we have geological features that allow the methane to seep up. But in deeper water, there are far less methane bubble streams.
That is really interesting. I think this canyon feature, just hearing you describe that is, I just like to think about these things in air. This is a 60-mile long canyon. If you were going to go hiking in something like that, that would be a massive hike to undertake. And we're, sort of in the upper quarter of that. If we're 30 miles offshore and it starts 15, so there's about 15 miles of canyon to our east, and it kind of narrowing up to the head of the canyon, which in and of itself would be a huge hike to go 15 miles up into a mouth of a canyon. But to know that then to our west, I'm pointing to my left. I don't know that left is the direction west is right now. There's another 45 miles of canyon to explore, and and it dives another 1,200 meters down. I kind of like to think about that, imagine that in my head, that you're like, okay, there's a view. It's descending and widening out to your left. It's rising to, a canyon head
to the east. That is interesting. I never thought about how you'd compare it to, like, say, the Grand Canyon.
Yeah. I don't think we could check. I don't know that that's the right
I mean,
scale. But, you know,
I-
thinking about a canyon
yeah.
or a feature near you, maybe, you
Right.
know, if you can imagine like a draw or a canyon around your hometown somewhere.
Yeah.
Was that just a fish that was moving that was causing that? Smoky little?
Was doing what?
I saw like a little cloud of smoke. I'm assuming it was just a flatfish causing it, but I wasn't sure.
Looks like more of those sole.
Yeah, it was
Probably.
yeah. Probably just trying to bury itself.
Yeah, it's so funny the way they do that. The flounder, they just kind of hang out. I haven't seen any of those here. Ugh. Sorry, I know everything in nature is beautiful. But
Not a hagfish
I have a hard
fan?
time. I have a hard time loving hagfish.
There's a Ropos pilot I know who doesn't even like to be in the control room if we're sampling them or anything.
I know who that is.
Yeah, no longer big, now medium.
Yeah, he used to be Big Keith.
Yeah, now he's medium Keith.
Yeah, I know. He's, yeah.
Hey Bob,
Watch
do you
change of video.
have a favorite squid? Oh, you're off SPL.
I was not on SPL.
Oh.
So a favorite squid, I guess everybody likes the vampire squid, right? Yeah, I mean, I
was gonna say, I was like on the edge of my seat. I was gonna be like, is there a huge butt? Everyone but me.
Well, I mean, I want to see a giant squid, right?
Uh-huh.
That would be
Oh,
the big
wouldn't.
deal, right?
Yeah.
Yeah.
He would definitely be my favorite squid if we saw one.
Have they ever been sighted,
Mhm.
spotted with an
Yeah.
ROV?
Yeah, a
I
couple
know.
times, no.
I know there's a big one in the museum in New Zealand.
Yeah, they have been. Dr. Edie Witter's work, her team has had success in the Pacific and in the Gulf of Mexico, seeing them come in, and they developed a visual lure that is the alarm response of the giant squid's prey. So the alarm response of bioluminescence blinking, like its food is there eating its food, you know, kind of 2 steps down that food chain. And they've had them come in on the cameras and gotten the footage, only footage of them live.
Wow.
Yeah. I know Dr. Edie Witter is writing a book and is about to release a book coming out sometime this year. So I'm really looking forward to reading that.
Ooh, yeah, I'll keep my eyes out for that.
How
Okay.
giant are they?
I don't know that.
Fairly big.
Really big.
Bigger than a mailbox.
Gigantic.
They like 20 meters or something?
Something.
But,
Yeah.
Yeah, maximum size at around 12 to 30 meters, which is 39 to 43 feet for females, and 10 meters, 33 feet for males.
Oh, the females are bigger than the males.
And I think, you know, there's something like the colossal squid are actually longer, but not as big in body mass. So that's where giant squid got in there. I like the Aspiritothus squid. That was a favorite of mine that had like its own float body, like an extended, you know, faux thin kind of like lobe extension.
There was a squid that we saw down in the Northeast Lao Basin, and it looked like a bird, and I think it was like the parakeet
Oh,
squid,
yeah,
I
the
can't-
cockatoo squid.
Yeah.
Mm-hmm.
Oh, very cool.
Yes, super
Beautiful.
clear with strange
Yeah,
googly eyes.
yeah, Yeah.
Oh, yeah.
All of its tentacles clumped on its forehead.
Yeah. Yeah.
Mm-hmm.
Beautiful.
Yeah, they have ammonia inside their body that they use as their float to fill up their mantle cavity.
Really?
Yeah. I don't know how.
Have you ever seen one?
Yeah, Nautilus has seen one a couple times. We've also seen the piglet squid, which is
Does it look like a little pig?
yep. They're it's wild. Their siphon. It looks kind of like a piglet nose.
Yeah, they're so
Um,
cute.
Yeah. Yeah, those are our pictures from our sighting. Yeah, that's a pig. That's the piglet squid.
Oh my gosh. Wow.
I still really
Aw.
love sea pigs. I think
Yeah.
these guys are
Oh,
funny
yeah.
too.
The stampede of sea pig.
Uh-huh.
Oh, that's cool. Someone wrote in, Edie Witter is hosting a virtual lecture through Cabrillo Marine Aquarium in San Pedro, our home port, in August. So if you want to learn more about giant squid lures, check out, maybe do a little Google search for the Cabrillo Marine Aquarium's lecture series.
That's awesome. I have a few friends that work over there. Emily, I think Val works there as well.
That's awesome.
Yeah. So shout out to you guys if you're watching.
Yeah, and shout out to Cabrillo Marine Aquarium, free to the community. It's actually partially owned by the Port of Los Angeles and the City of Los Angeles, so it's a great, we have a lot of great partners that do marine education, but if you find yourself in Los Angeles, it's a great opportunity to learn a little bit more about the ocean right down by the beach.
So
It's watch change time.
it's watch change time around here. Just in time for Tamara, our lead scientist, to come in and be able to sample her hydrate and gas bubbles, which we're
Yeah. Chris,
going to find.
yeah. How far are we from the target, Chris? Oh.
Okay, so
375.
375, cool.
we're close.
Onward, so lots more exploration left to go.
It's going to be an exciting next 4 hours.
Yeah.
4, 5, 6, 7, 8. 4, 6.
Yeah, keep hanging out with us. We'll hand it over to the other team after some lunch and keep answering questions.
Thanks, Megan. And thank you, Taylor Ann, because without you, you and Megan, there'd be no biology here.
Holding it down for the biology.
Appreciate it. So we're about 350 meters from our target, where we're hoping to find some hydrate and
you need to slow
methane
down.
in the solid form and some gas bubbles, methane gas, to be sampled. For our Earth-Ocean Interactions program.
It's still tugging.
Principal Investigator Tamara Baumberger.
Look up a little with the...
So we have a little bit of stuff going on here.
You're tugging me, that's why you're not, I can't see you.
Yeah, look up a little with your camera. Argus camera.
Well, no, I can't see you because you're tugging me.
Oh, I'm pulling your head around? Oh,
You were, yeah. So now I'm getting back in.
So with that bubble cam, be very careful. The stick is proportional, so move it nice and slow. And don't drive it up above the horizon, because you know what it's doing, right?
Yeah.
Okay, here comes Tamara.
Yeah, you're way ahead of me.
Oh, it's because he's got this thing all jacked up. Also got it on auto center. How do you get it off of auto center?
See? Tugging.
Yeah, I'm off to the south of you. I see what's going on. I need to change my heading and come out in front of you there.
What heading are we supposed to be going? We're going
I can
north.
see by the track boat.
You want me?
That's what I want to see. Thank
You want me to maintain this 15-meter delta,
you. Sure.
or come up a little?
Hey, let me get a little. Get lined up here and let me get out in front of you. We're moving, so they're streaming behind us, so it's not a big deal. And it's flat. Can you zoom in and make those 20-meter divisions? Yeah. If you turn off the auto center, you'll be able to see the ship.
I wonder who's working Norby.
Yeah, but I don't need to see the ship. It's not a big deal.
Who's working Norbit, if it's on?
K2's got it on his program.
It's on something separate?
What's that?
It's not on.
No, it's on something he's running.
Oh, okay.
Thank you. Don't like auto center. This 20-meter thing helps me figure out where I am in relation to Argus. Okay, Mike, should be able to bring your head around to 045. Let's try 030. If you want to be super anal, you can get the ship's course over ground. And it's about 030. Got stuff lined up here.
What was that? Yeah. Yeah. Yeah, because I'm like 15 meters off right now, actually. No, I'm 15, yeah. I'm going to take it around. Is that okay with the, I'm going to take bubble? Oh, wow, look at all the starfish. Oh, wow, look at the big boy.
It's a really great shot.
I'm coming up. The dark ones and red ones and oh, look, more fishes.
I like how pink it is.
Yeah.
Like a whole bunch of Patricks just lounging.
All ones are like super dark. Or maybe it's just the lighting. Oh, I guess it's the lighting.
Stuck out to me as well, that one on the bottom.
Yeah.
Oh yeah, that one does look really dark.
But I guess in Argus's cam, they all look really dark. So.
Yeah, but you can't really trust Argus Cam because they don't want to take my idea and put a color grading on the top of her. I just got to slap a sticker on there, and then video could just like white balance her Argus. It's like Argus now in Technicolor.
Is that new? Yeah, right there. Do they match? Yeah, the ship's anemometer and the anemometer we use from the systems. Most of the time they relate.
Boop, 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 boop. I want to up the brightness on this thing. I need to play with that later when we're not doing anything or ask them to up the brightness on this one.
The ship's 63 meters away from its position.
63 meters away from which position?
Where we're heading, wherever.
Okay.
Put in the waypoint.
Yeah, so this waypoint 4, that's another area where we saw a bubble stream last night in the multi-beam survey. And also in the same area, there has been some exposed hydrate observed on a 2019 cruise led by the USGS. So we're going to check this area out, see if we find the bubbles, if there's exposed hydrate to sample, and also look for the seep fauna.
Okay.
We have Emil saying hi, who sails out on Nautilus with us sometimes.
With this sonar, or?
And he's just bringing up a memory of how the sea cucumbers in Astoria Canyon on past dives were aligned seemingly with the axis because of the strong bottom currents there. So
that's
cool.
right. There were many, like just all aligned in the same orientation. Yeah, it did look very interesting. So who was that?
Emil.
Okay, yes, yeah. That was actually on our cruise. I think
Yeah.
I sailed with Emil, yeah.
It's approximately where waypoint 4 is. Yeah.
Copy that.
Oh. That looks sort of like a tanner crab.
Moving so fast.
Hard to keep up. These sea stars kind of look like blood stars, Henrikia. Now that we're zooming in.
No.
But I don't know if they're quite spindly enough.
Zoom out.
I feel like we're falling through space. We're going to crash. Seeing some bright stuff. I don't know much about the orbit, but
Full wide.
okay.
Now I see some bacterial mets here on the side coming up. So we're getting close to the side now.
The ship's in position. Yep. Bridge nav. You can just hold position, please.
Sorry guys, I wasn't talking on SPL. I had a auto altitude. Well, I always blame the computer, I always blame the equipment, not the operator. But I picked up a bunch of mud there. I'm just trying to clean it off before we come over the site.
Yeah.
Yeah.
Something bright up to our 90 degrees to us, or won't
Argus.
270.
Oh, it's going to stick with us for a while.
The Norbit is picking something up almost directly. Well, now it's to your left.
Roger.
Oh, that's right. It's not on here.
You're looking at this screen. These are the examples because I'm pretty unfamiliar with this.
Yeah, can't get there from here, unfortunately. Oh my God.
Ooh, more Matt.
Can we? Yeah, exactly.
So we're just about over waypoint 4 now, right? Sorry, can you repeat that? We're just about over waypoint 4 now, right? Yes, we are just about over waypoint 4.
Where is the waypoint for it?
Yeah, so let's look around here a little bit and see if we
Back to
find
waypoint 4.
bubble streams, hydrate, clam beds, more bacterial mats, just kind of get an idea of how the seep is looking like. Are we still cleaning off? Or
Can you put Argus over waypoint 4? I'm as cleaned off as I can get for now. We just Argus is 20 meters northeast of waypoint 4, so we're going to move it back a little bit.
yeah.